Welcome to the Explainer. Look, if you've ever stared down a math problem and felt like it was written in literal hieroglyphics, trust me, you are not alone. Today we're going to build a completely practical mathematical toolkit to help you conquer some of the most frustrating problems you're going to face in sources like the Cambridge IGCSE syllabus, specifically 0580. We're breaking down the logic behind the numbers. By the end of this, everything from calculating massive financial loans to baking the absolute perfect batch of cakes is going to feel like second nature. Let's get into it.
Okay, here's our agenda for today. We are equipping you with 4 heavy-hitting mathematical tools. We'll start with the magic of compound interest, then unlock reverse percentages, move on to solving direct proportion, and finish up with dividing quantities by ratio.
So Section 1. The magic of compound interest.
Compound interest is one of those concepts that literally shapes the global economy. It shows us how time dramatically affects money. And it's not just about a flat, predictable rate. It's about interest building on top of interest. Snowballing, basically. To see how powerful this really is, imagine a shipping company. They need a brand new cruise ship, right? So they borrow $70 million at 5% annual compound interest. If they wait 3 full years to repay this massive debt, how much extra are they going to owe strictly in interest? Just think about the sheer scale of those numbers for a second.
Well, we can solve this with our very first tool, the compound interest formula. Now, don't let the letters intimidate you here. A is simply the total amount paid at the very end, the whole shebang. P is our principal, meaning that original $70 million they borrowed. R is our 5% rate. N represents the number of interest payments made in one single year, and since the problem says it's annual, that's just 1. Finally, T is our overall time, which we know is 3 years.
Right, so let's plug those numbers in. We put 70 million in for P, 5 for R, 1 for N, and 3 for T. That gives us the total amount they owe. But wait, the question asks just for the interest. So we have to subtract that original $70 million loan from our final calculated amount. When we do that, we find the staggering interest paid is over $11 million. Specifically, $11,033,750. No way, right? But that is the absolute magic, or honestly, the danger of compound interest over time.
All right, Section 2. Unlocking reverse percentages.
Now, reverse percentages often trip people up. Why? Because our brains naturally just want to calculate a percentage of a given total. It's what we're used to. But what happens when you only have a piece of the puzzle and you need to find the whole? Let's consider this scenario. Ahmed answered 23 questions correctly on a test, and that represents 92% of the total marks. So how do we logically figure out how many questions he got wrong? We actually have to work backwards to find the total number of questions first. And this brilliantly illustrates our 3-step reverse percentage method. Step 1. Identify what your current number represents. In this case, 92% equals 23 questions. Step 2. Find out what just 1% is. We do that by dividing the 23 questions by 92, which gives us 0.25. And finally, Step 3. Find the full 100% by multiplying that 1% value by 100. So, 0.25 times 100 gives us 25.
Following those exact steps, we find the test had a grand total of 25 questions. And since we already know Ahmed answered 23 of them correctly, simple subtraction gives us our final answer. 25 minus 23 means Ahmed got exactly 2 questions wrong. See? By finding that 1% first, reverse percentages literally become a breeze.
Moving on to Section 3. Solving direct proportion.
So direct proportion simply means that as one value increases, the other one goes up at the exact same rate. Think of, say, pottery workers getting paid per plate they produce, or a factory machine pumping out products over a shift. For example, look at this problem. If a bottling machine fills 500 bottles in 15 minutes, how many will it fill in an hour and a half? Now be careful. The hidden trap here is the units. You absolutely cannot compare minutes directly to hours. You have to convert that 1.5 hours into 90 minutes before you do anything else.
Once your units actually match up, you basically have a choose-your-own-adventure situation between 2 valid paths. On one side, you've got the ratio method. This sets up a direct equation comparing fractions. X over 90 equals 500 over 15. On the other side, you have the unitary method. This is where you first figure out how many bottles are filled in a single unit, in this case 1 minute, by dividing 500 by 15, and then you multiply that result by your target time of 90 minutes.
And here's the best part. Regardless of which path you choose, as long as you set up that direct proportion correctly, it leads you to the exact same satisfying result. The machine is going to fill 3,000 bottles in those 90 minutes.
It's a perfect, real-world demonstration of how mathematical scaling works. Finally, Section 4, Dividing Quantities by Ratio. This tool is incredibly practical. I mean, it's essential for everything from mixing concrete to fairly dividing $8,000 in company profits among business partners to something we all love, food. Let's say we want to scale up a recipe from 18 cakes to 72 cakes. By identifying the ratio, we can immediately see we need exactly 4 times the amount of each ingredient, right? Because 72 divided by 18 is 4. So we can use a simple table to flawlessly multiply our butter, flour, sugar, and currants by 4. The ratio of those ingredients to one another stays perfectly intact, and the recipe works.
Now, let's try dividing a massive total quantity into a specific ratio. Imagine a factory produces a total of 48,000 cars. The colors red, blue, white, and green are produced in a 7:5 to 3:1 ratio. The crucial question we want to answer is, out of all those 48,000 cars, how many are white?
To divide any total quantity into a given ratio, you just follow a super simple 3-step process. First, add the ratio numbers together to get the total number of parts. So, 7 plus 5 plus 3 plus 1 equals 16 total parts. Second, create a fraction for your target group. White is the third number in our ratio, which is 3, so its fraction is 3/16. Finally, step 3, multiply that fraction by the total amount of cars. That's 3/16 times 48,000.
When we calculate that out, we find that the 3-part slice out of 16 total parts equals exactly 9,000. So 9,000 white cars roll off the assembly line. By breaking it down into total parts first, you can easily find the exact value of any slice of the pie.
So here's the crucial takeaway. Whether you're mastering a Cambridge syllabus exam, evaluating a massive bank loan, or simply scaling up a small business venture, these 4 tools give you a rock-solid blueprint for solving proportional puzzles. You now know exactly how time scales money, how to trace percentages backward, and how to scale and divide ratios perfectly. But my final question to you is this: what complex real-world problem will you decode next? Take this toolkit and go conquer the numbers.